Hi, my name is Matt, and today we're going to work on this 1999 Chevy Malibu with a 3100 engine. It has a check engine light with a P0113 and a P0111 intake air temperature sensor codes. So in this video, I'm going to show you several ways to diagnose your air temperature sensor to see if you need one or not. Both using a scan tool and not using a scan tool for those of you that don't have one. And then we're also going to afterwards talk about what the IAT, the intake air temperature sensor is, why you need it, have an understanding of it for those of you that are interested. So should be pretty easy. Let's go ahead and get started. All right, sorry for the mess here because I'm doing actually a whole bunch of other stuff on this car, but most of it's maintenance, and this is the more interesting thing. But this is your air intake box with your air intake snorkel. On most cars, you're going to have your IAT somewhere in that snorkel. This is your mass airflow sensor on this model here, and some models the IAT will be part of the mass airflow sensor. On this, it's a completely separate unit. It lives in the hole on the side of the snorkel here, and this is actually the unit right here with the connector. The IAT is actually just a thermometer. It tells the temperature of the air, and the engine uses that information for some stuff I'll explain after the video. Oh, and by the way, on some car models, this guy is not in the air snorkel. He's actually located on the intake manifold somewhere, or on the plenum. And that's kind of an unusual location because of the heat soak, the higher temperature. But of course, the software in the PCM is designed to calculate for the higher temperature. All right, I'm going to set up my scan tool here, but again, we will cover doing this without a scan tool as well. While that loads, I just want to share an important philosophy. Very important you understand this. We're going to talk about exactly what that code says and how we're going to diagnose it and why. Do not look at that code and see blah, 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 intake air temperature sensor, blah, 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 and think, oh, I need to get an air intake temperature sensor. If anybody tells you that you need to replace the air intake temperature sensor based on this code alone, if you go to any of the common chat rooms for help, you're going to get tons of people that will tell you to replace your intake air temperature sensor. And what I'm telling you right now, if you change the air intake temperature sensor on this car based on that code, you're an idiot, even if it fixes the problem. And there's a lot of people that just don't understand why that would be true, even if it fixes the problem. And if that's the case, think long and hard about it. The reason is because there are other things that can cause that code besides the sensor. You have to test to make sure that the sensor is faulty. And of course, that's what we're going to do. So let me go ahead and get started up, and I'll give you a look at something. All right, I couldn't actually show the trouble codes because I forgot I disconnected the battery when I was doing some other work on the car, so the trouble codes are gone. But again, it was a P0111 and P0113. But what we can see is the intake air temperature sensor is reading minus 38 degrees, and it is not minus 38 degrees. So this actually, the way the IAT works, there's a 5-volt reference signal. The IAT is a thermistor, and I'll explain all this at the end of the video. But basically, the hotter the temperature, the less resistance on the 5-volt signal. So if the hotter the air temperature, the more voltage would go through. And of course, the colder the temperature, less voltage would be able to go through the sensor because there's maximum resistance. So what this indicates is there's probably an open in the system. Could be a bad sensor, could be an open in the sensor, could be something in the wiring. So the test is going to be really easy. We're going to do it both with a scan tool and of course without a scan tool. But what I really wanted was a PID for voltage on here because it would have been easier to look at voltage. And admittedly, I'm a little worried about this because I normally, when the sensors are bad, I kind of see them short out, so you would read like 140 degrees. But I'm going to show you the real quick scan tool method to do this. When I unplug the sensor, then it should change. But I don't think that's going to happen because of this open situation, so it's probably not going to change. And that's kind of a problem. All right, it's unplugged. And it didn't change. So if this number, or if we saw voltage on our scan tool, if that number changed when removing our sensor, then you know the sensor's bad. That you're pretty much done, actually. You can do some of the other tests that we're going to do, but you would be pretty much done. So I'm going to just plug this in one more time just to be sure, because now I'm a little worried about that. I thought this was going to be easy. What this is telling me is this is not a bad sensor. We've got some other issue here. So I plugged it and unplugged it and it didn't change. So what did I just say a few minutes ago? This is a great example of that. If you change the IAT on this car, you are not going to fix it. All right, so we're going to do our non-scan tool testing, probably quite a bit of it for the rest of the video because this was really unexpected. I really thought this was going to be a lot easier. So what I'm going to do is look for voltage, and again, the way that this guy works is through a 5-volt reference signal. Very simple, 2 wires. We've got a tan and a black. The tan is going to be the signal wire, so let me see if I can get out of your way here. Hang on a second. All right, and what I'm looking for is for 5 volts, which we're not going to find. And we've got 25 millivolts. I don't think it's going to be a short to ground because of my limited understanding of the wiring. I do believe we're going to have an open here. So let's see what else we can do to test. All right, the other thing I'm trying to do here is to back probe the connector just to see if the open is in the connector. I was looking for 5 volts there, and I am not finding it no matter what I do. All right. We got some wiring to do here. But before we do that, let me show you another way to check an IAT. Of course, one of the other things, if I can prove that this IAT sensor is actually functional and working, that would be even more evidence and could help you in other situations. So let's go ahead and talk about how to bench test an IAT. All right, so with our IAT removed, you see we do have 2 simple pins in this guy. So he's going to be very easy to test. Remember, this thing is basically just a thermistor, which means a thermal resistor. It is going to decrease resistance the hotter it gets. So very easy to test using our ohm meter, and we're going to use this blow dryer. And I have opted for a Vidal Sassoon model because if this test don't look good, they don't look good, which means I still look dashing. All right, and incidentally, I think I forgot to mention, but on those previous electrical tests in the car, you want to make sure that the ignition is on, of course. I thought that was obvious, but I don't believe I mentioned it. All right, and I'm going to very carefully place my leads so that they don't touch. And we can see that we've got about 2.6 ohms of resistance there. And again, this is going to be a thermistor that when we heat it up, it is going to reduce resistance. So let's see if it does that. You can see it's dropping. All right. So this is conclusive test that this intake air temperature sensor works. Once again, 100% confirmation. We've got some kind of wiring problem in the car. Changing this sensor will not fix the problem. All right. Welcome to the DBOC, the Dry Erase Board of Knowledge. So what is the IAT, the IAT, intake air temperature sensor, and why is it important? It is important because in order to create the exact correct amount of air-fuel mixture in the engine has to know the density of the air, or the weight of the air per volume of the air. And this is done by using the intake air temperature sensor because colder air is actually more dense than warmer air. So for the same volume of air, say a gallon of air, if the air is colder, it would actually weigh more than that same gallon with warmer air. And this is also comparable to, say, you have a gallon of water and a gallon of pancake syrup. Well, they're both 1 gallon of liquid, but the pancake syrup is way more dense. It's going to have much more weight. So it's very important to get exact fuel-air ratios to be able to calculate the density. And density would be in this formula like this. So here's the problem. The engine computer is very good at measuring the volume of air. It has no problem with that. This engine uses a mass airflow sensor that's very good at detecting how many gallons of air are coming in. But the engine has no way of actually weighing the air to know the relative density. So that's done by the IAT. And what the IAT does is, if we look at it on a graph, remember the IAT works through voltage. There is actually going to be, remember that 5-volt reference signal that goes into the IAT. The IAT is a variable resistor that changes with temperature. So you'll have a lower amount of voltage than 5 volts coming out. So here, let's put X volts there. And the way this works, of course, is, remember with our hairdryer experiment, the higher the temperature, the lower the resistance, so the more voltage, and that's exactly what the IAT sees on this graph. The higher the air temperature, the more voltage that we can compare before and after the IAT. And this is actually calibrated so that based on the voltage, the IAT knows what the temperature of the air is. And then there's another mathematical formula that will tell you the temperature of the air is going to have this much density. So therefore, because it knows the volume of air and it knows the weight of the air, it can now calculate the density. So that's what the IAT does. Now, the specifics on how it works is what we are going to have to investigate. So in your engine computer, it's going to send out a 5-volt reference to your IAT, which of course again is the variable resistor. All right, sorry, my superior drawing abilities failed me there, and to be honest with you, I'm not really sure what the variable resistor symbol is, but it's something like that. And then it returns back to a ground in the computer. And of course, again, being a variable resistor, the higher the temperature, then the higher the voltage that we'll see, because the lower the resistance. All right. So here's what our problem is. What I would have liked to see is when we unplug the IAT, there is actually, we were measuring with a voltmeter here. So we've got our voltmeter here. We were measuring here and here with the IAT unplugged, and I was hoping to see 5 volts. Well, of course, the PCM also does the same thing because it's looking for the voltage differential here. If the IAT was bad, when we unplugged it, we would have seen our 5 volts coming here, and of course 0 volts here. So when we hook up our volt ohm meter, we would have seen 5 volts on the volt ohm meter. Awesome, we know the signal wire is working. We did not see that though. So really what I'd like to do would be look for 5 volts at the computer with a voltmeter tied up here and here. And if I see 5 volts from the PCM at the power and ground, I'm really going to be happy. Means the computer is really good. But if I do not see voltage here, well, we've got a problem. We're either going to have like a bad pin at the computer or something, or more likely we're going to have some type of internal issue with the computer, which would almost certainly mean that the car needs a new computer. So I'm not sure how easy it is to get to the computer on this. And again, with my limited wiring diagram capability, even if I get to the computer, finding which wires, because they probably change colors by the time they get to the computer. What I may do is go ahead and do a quick visual inspection, see if I can trace this wire from the IAT connector on down, look for an opened, then I'll be really happy. And if I don't, then I guess we're going to go ahead and attack this computer, and I'll have to find a wiring diagram for that. All right, guys, and my apologies. As you probably can see, electrical is really not my strong point at all. Being self-taught, I just don't have enough experience with electrical problems like this. So do it yourself, guys. I'm going to really sell out on you guys. I'm really sorry. But what I'm going to do is use something that most of you guys probably don't have. But I'm going to use a signal tracker. And what this is going to do is it's going to send a signal that can be detected by this remote sensor, and it's going to send a signal down that line, and then I'm going to use this sensor to pick up where that short or open is. I hope it's not at the computer, of course, but what this is going to do is make my visual inspection a lot faster than digging through the wiring and stuff. And you know, like I said, I really just don't want to dig out a computer right now. I've got a driveway full of cars right now. I live in a residential area, and I'm always sensitive about that. I've got to get this thing out of here. So my apologies for not showing you the computer connection thing and all that. But to be honest with you, I would spend longer finding a wiring diagram than I would just go ahead and do this. So on the other hand, though, this is a really sweet tool, and I don't use it all that much. But boy, when you do need it, it's unbelievable. Let me show you how this works. So what I'm going to do is connect my signal sending unit up to the battery. All right, and that sound means that it is connected to the battery. And it gives you a little indicator here whether you've got an open or a short to ground. Well, of course, I've got an open because my signal wire isn't connected to anything. And the trick is, what you do is use this signal detector, and what it will do, because there is signal being sent through here, we can calibrate it up and we can see that it's following. You can use it either direction, but you can see it's just, all it is just a sound sensor. But I like looking at the light. It actually shows you, if you have a short to ground, it shows you which direction the short is going to be. With this being an open, of course, those arrows are useless. And we see that the signal disappears when we find the open. So this is the region where our open is going to be. So what I'm going to do is connect this up to our signal wire. What we're going to do is go ahead and follow along. Oh, it can't be that easy. There's no way. Unbelievable. So it looks like there is an open right here. Oh, if that's the case, I'm just going to be thrilled. I told you this is a cool tool. So what we're going to do is we're going to open this harness up in here and see if we can find where the problem is. That's going to be sweet if that's the case. All right, so after digging into this, I found that actually somebody tried to make their own repair here that didn't seem to hold very well. So that seems like pretty good news for me, I hope. So what I'm going to do is go ahead and hook up my voltmeter to these leads, turn the ignition on, and let's see if we get our 5-volt reference signal now. All right, that is awesome. That is super awesome. So this was more difficult than I thought, but also considerably easier than I thought. One of the things you really want to be careful when you do this kind of thing, you want to make sure that you don't short to ground now, because without resistance and everything, sometimes that can fry the computer. Not on a circuit like this, I don't think, but this is huge. So basically, I just need to repair up this wiring, and this should work much better. Yeah, where's Eric the car guy when you need him? I hear he's pretty good at soldering. But let me go ahead and fix this, and then let's see if the system works. All right, we have a fix. I've got my same IAT hooked back up after fixing the wiring, and we can see that we've got our temperature somewhere around 75, 76, which is just a couple degrees shy of what it actually is, but I'm plenty happy with that. So I got really lucky on that repair. All right, sometimes you catch a break, and man, I really needed one here because I was really expecting that to be a lot simpler than it was. And it turned out to be a lot simpler than I thought it would be after I found it wasn't the IAT. But just in case you're wondering, the wire tracing unit that I used is the ECT 2000 from Power Probe. I bought it as part of this whole Power Probe 3 combo kit at a pawn shop a couple years ago. And as you can see, it's a huge time saver if you're tracking down an electrical problem. Really awesome. Totally paid for itself there as far as I'm concerned. So I know what you're thinking. You're saying to yourself, damn Matt, why can't all car repair videos be like yours? And the reason is actually because other people besides me make car repair videos. But I'll continue to do the best that I can. So thanks for watching. Thanks for subscribing. I hope you found this helpful. We'll see you next time.